Cool, let's get started with today's LeetCode problem. I need to sign in first. Cool. Let's switch over to Kotlin. Given two binary strings A and B, return their sum as a binary string. A length and B length are between 1 and 10 to the 4, consist of only 0 or 1, and each string does not contain leading zeros except for the 0 itself. Okay, this is an interesting one. So there's no guarantee that A and B will be the same size, or rather the same length. So we need to figure out which one is the larger string. So here's what I'm thinking. So let's actually increase the font size as well. It's 15. Yeah, that's better. So we'll say that so we have two strings, A and B. Get the longer of the two. And this would just be a size comparison. And once we get that, we probably don't need to do this. Let's hold off on that for now. Actually, we should. Because then this gives us the upper bound for our for loop. Then, after that, we can iterate over the longer string. And when we iterate over the longer string, we can add them given the cases. So let's just do that. That would be easier. So we have one case where it's 0, 0. That just returns 0. We'll have it as, just to make it easier, this will be A, this will be B, and this will be C, which is the carry. That'd be 0, 0, 0, 1, which would be 1. And we can have this as S and C. Then we have 0, 1, 0, which is just 1, 0. 1, 0, 0, which is also 1, 0. Then 0, 1, 1, which is 1, 1. Actually, no, it'd be 0, 1. Because 2, so binary, you carry that. Or 1, 0, 1, which would also be 0, 1. And then 1, 1, 0, which is also 0, 1. And 1, 1, 1, which is 1, 1. So those are our cases. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, because 2 to the 3. So we have our 8 cases. And then we can use, is there a string builder? String builder Kotlin. String builder. We can create a new string builder, an empty string builder, then we can append to it. And we're running, actually we just switched this to version 1.3, because that's the version that LeetCode is stuck on, unfortunately for now. So let's give this a shot and let's see where we end up. let's see. We're gonna need a val to our we'll need a val to our longer string. Which is, and actually, since I'm not sure how to write this in a concise way in Kotlin, I'm just going to do this. I'm going to do this in the sort of explicit, or I forgot what they call it, Kotlin. That's more similar to how you do it in Java. Shorter string, and we'll say if a size, and this is a property I believe, is greater than b size, longer string is a, shorter string is b, else longer string is b, shorter string is a. So now we can do longer string, and we'll run a for each indexed. And the reason why we're running a for each index is because we need to check if the index is out of bounds for, so this when the index is out of bounds for the shorter string. So when value is equal to 0, and we'll also need a var carry. And we'll have this be set to a character 0 for now, just to make it easier on ourselves when we're comparing. So let's have our first one be index is greater than shorter string dot size -1, so that's out of bounds. So when that happens, then we're just going to say, oh, and we're going to need a val string, we'll call it return string builder. And I believe that's how you initialize that. So that'll be our string builder. Then our return string builder. Actually, in the case that b is or the shorter string is 0, then we need to check the longer string and the carry. So actually this will be another when value is 0 and carry is 1. And we can throw this like this, and actually we can copy paste this and just swap it over. So we should have a reference to value in here. Then we can say return string builder dot append 0. And we'll also need to, should I separate it out? Because I'm thinking that carry will also need to be set to 0. Yes, screw it. I don't think it's a huge deal here, so I'll just set it here no matter what. And then else, or actually value is 1 and carry is 1. Then string builder append, we need to append also a 0. I just realized we're going to be doing this in reverse, aren't we? Carry is 1. Yeah, because append it to the end, right? Yeah. So this takes care of or a shorter string get index is equal to 0. So that takes care of really one. So this case is taken care of, this case is taken care of. All 4 of these cases are taken care of with this, because either the shorter string is too short or it's a 0, so we don't need to worry about that. Oh, but no, but because what if the longer string has an index or has a value of 0? Okay, I'll have to think about this a little bit more. Let's see. Okay, it's been a little bit since the jump cut. I decided to move my camera to the other side since I just noticed that you weren't able to see sorry, the code on the right side. But I realized that there's probably a better solution to this. Rather than doing this, we can say val shorter char is equal to, so it's either, so we can do shorter string, and I believe we can use get or null at index and use the Elvis operator. So if it is null, which means that it's not in the index, we can quickly check the string. That's not the right one. I want the string classification, basic type strings. Can we do a get or null? Oh, we'll see if that works, right? Get or null. Actually, text get or null index. Okay, cool. Yep. Awesome. Okay, so I think this works. And if it is null, which means that's out of bounds, we just do 0. So when this is going to be value is 0, shorter char is 1. Or shorter char is 0 and value is equal to 1, then this would be 1 and 1, so return string builder. Actually, this would be 0, and this would be 1 because 1 and 1 is 1, 0. Otherwise, we can keep carry as it is, right? Because then it would be 0, so 1 and 0 is 1 and 0. We don't need to modify the carry at that point. So now we've tackled these 4 cases in the middle. Sorry, these 4 cases in the middle, where one of them is 0, or one of them is 0 and the carry. Then we also need if value is 0 and shorter character is 0. If our carry is 1, then our string builder append 0, else return string builder append, 1, append 1 if carry is 1, append 0 if carry is 0, because then all 3 are zeros. So now we've covered those cases, so we've covered these 2 cases. We've covered these 4 cases. Now if value is 0 and shorter character is also, this should be 1, this should be 1. And if carry is 1, then we want our return string builder to append 1 and our carry to also stay the same, so actually we don't need to change it here. Otherwise, if it's 1 and 1, we want 0 and carry to be 1. Okay, and we want to carry the overflow. So at the end of this when statement, or at the end of this loop, we want to say if carry is 1, then we want our return string builder append a 1. And this is in case we have basically an overflow. So now we have the case of, and technically we can actually reorder this to be a little bit easier to follow this. So our first 2 cases here, if we have 0, 0, then it's 0, 0, 1, then we append 1. And if it's 0, and we should say carry is 0 in this case. So 0, 0, 1, we append 1, carry 0. Otherwise, append 0 and carry is 0 by default in that case. So we don't change it. Then we have 0, 1 in either of the cases. So these 4 cases here, basically. If the carry is a 1, we want to set our sum to be 0, because then we have 1, 1, so we should have carry 1, sum 0. So that's what we do here. Let's see. If carry is 1, sum 0. Right, okay. So basically we just move the carry forward. Otherwise, we return just 0, 1, so that's 1. And no carry here because carry is default 0. Then the last 2 cases are if they're both 1, 1. Then we have, if the carry is 1, then we have 1, 1, 1, so we should have both the sum and the carry is equal to 1. In this case, the carry is already 1, so we don't need to change anything. If they're both 1, however, and the carry is 0, then we need to append a 0 and set the carry to 1 ourselves, in this case, when the carry is 0. Then, of course, if the carry is 1 at the end, then we should account for that and also append that on top. There's no way to have multiple carries in binary as far as I know, so we only need to do this once. And of course, at the end, we need to actually return our string, return string builder. Is there a reverse method on here? So string builder. Reverse. And then to string, I think. So this really get our null part, I think, is really, really useful in helping to simplify the code a lot. We've covered all the cases, all the 8 cases that it could possibly be. We've done a little bit of evaluation here just to make sure that everything is proper. And here I'm not sure if we need to declare the type, but I think it's for the best that we do because we're not initializing the values right away. Technically here we can probably do like an equals a.size greater than b.size than in a weird if-else case, but I'm just going to make it more explicit here. And we could also include a case where a and b are also both empty. That would be another thing to consider. If a and b are empty, we could just completely cut to the chase there and just return a 0. Well, actually, they can't be empty in this constraint for the problem, so that's fine. And the reason why we need to reverse the string at the end is because technically we're working backwards, because appending will always put it left to right, in the same way that English alphabet works. However, binary is right to left in terms of increasing value, so we do need to reverse it. So I think this will work. Let's give it a shot and let's run our code and let's see if we need to make any changes. So let's start with just one example case and then we'll see where we need to go from there. Right, I forgot the arrows in this case. So I need an arrow here, an arrow here, and an arrow here for our when statement. So that's the block that they're going to be running for each of the when statements. Late init is only allowed on mutable local variables. Interesting. And we also have an unresolved reference on size. Okay, so I guess size is not the thing to be using here then. Unresolved reference. So is this the one that I want? No. I just want the length of the string. Is it just called length? Mutable. I get that much. I'm just trying to figure out length. Okay, it is length. Okay. So let's actually spell that correctly as well. Late only allowed on mutable local variables. Okay. So I guess I do have to let's say if a length is greater than b length, then a else b. And we can just copy this part and just flip it over. So here, whoops. else a, and we can get rid of these late init values since apparently they don't work on immutable values, which I guess makes sense, right? Because late init, you can't reassign it to you can't reassign the reference in a val, right? So I guess that does make sense. Hope this works. Not too sure. Okay, so it seemed to work for 2 of our initial cases. Let's also toss in this one. Okay, what went wrong here? Our output was that. Our expected output was that. Val is there. So we have our val there. Zero, one didn't. Value 0, shorter char. Interesting. Because in this case, we'd actually be starting from here. So 1, 1 produces 0, 1. So we start with the 0 there. We'll have start with 0, 1. Then 0, 0, 1, so 1, 0. Then we have 1, 1 again, so 0 here, then 1 here. Then again, so 0, 1 here. And then we dump the 1 here and 0 there. Well, that's annoying. Interesting. So I think this might actually have something to do with the order in which we're actually doing the operations from left to right. Because these operations do make sense. 1, 1 is 0, carry 1. Then 0, 0 with carry 1 equals 1. And so on and so forth. All of this makes sense. Which makes me believe that we can't work with left to right in the way that I am expecting. So what if I do something weird and pull a reverse on the string here? So now rather than adding 1, 0, 1, 0 and 1, 0, 1, 1, we're actually adding, we'd be adding 0, 1, 0, 1 and 1, 1, 0, 1. Right? And in this case, we can pull our S and C. We get left to right, so we get 1, 0. Then 0, 1. Then 0, 0, so 1, 0. 1, 1, which is 0, 1 again. And then we'd carry the 1 out. So then we don't reverse at the end. We just bust out a toString there. Is there no... I mean, this is wrong because I need to call the reverse here. But is there no string dot reverse here? Do we not have a string to reverse? We have a reverse for the string builder, but we clearly, I guess, don't have one for the... Let's see. Reverse. There is reverse with an ED. But that's a collections one. I want the string. Which one's the one that works with strings? I think there's one for text. We could do as sequence, but okay, it is reversed. That's weird. So it's reversed for the string builder, but reversed for the string? Let's fire up the test cases, the example test cases, just to make sure that this doesn't bung anything up. Now we're getting bad inputs for... We're getting bad inputs for the first one. Interesting. We're getting bad input now for 1, 1, and 1. Let's see, 1, 1, and 1. That would give us an S and C of... So that'd be 0, 1. Then 1 and 1 is 0, 1 again. Then we'd get 1 here and 0 here just as the carry. And that's not correct because when we add it here, when we have 1, 1 and 1, 0, we would get we'd start with a 1 here and a 1, 0 right there. Maybe I'm overthinking this. Right, because when they're different length, then the position that they're added in moves. So we need a way to sort of pad them out so to pad out the shorter one. Because otherwise then we're adding the ones we're adding it in the ones place rather than the wait, no, that is correct. Sorry, it should be 0, carry the 1, so 1 1 and then 100. So it is the same. So we're reversing it. We're reversing it to add it. Then we're appending it, so we're adding it backwards. So we need to reverse it again? That seems odd. I think it does make sense though, because we're reversing it the first time, iterating forwards, then we're constructing the string. We're constructing the string technically backwards. In a right to left fashion, because that's how we're computing it, right? Or sorry, left to right. So then we need to flip it back to right to left. Okay. This is a lot of reversing. So this one would be linear, so this would be O of A or O of B. This would be O of A or O of B. Or B, A. Because reversal. Then we need to iterate over both, or the longer one, this one would be amortized as, right? Because this just technically it runs as long as the longer string is. Then we reverse it again, and the combination, the binary addition of two strings, of two numbers in binary as strings, can only be one character longer than its two inputs, or really in the case of this, it would be longer than the longer of the two strings. So this would be linear as well. So this is multiple times linear, but I think it's still technically linear. But I think we've worked out most of the issues with this, and let's give it a submit and let's see where we're at. LeetCode is kind of weird in that I'm not sure in terms of the speed. I think having about an average speed generally means that at least you're in the right direction in terms of the algorithm. And so for 52% in runtime and 60% for space, I think I'm fine with that. So that's going to be it for this video. Just, again, number 67, add binary, and yeah, hopefully you enjoyed, and I'll see you for the next problem.